Before we get started with the panel discussion, one thing I want to do really quick, I did mention the 4 electrical engineering students, Dayon, Anis, Josh, and Richard, and at that time the musicians, Ross and Jason, were not here yet, but there is an anonymous donor who has been quietly behind the scenes funding a lot of Eric Dollard's work, and that's about all we can say about it. And when he knew this conference was going on, he donated some money to cover conference costs, lodging, some food, different things like that for electrical engineering students, to encourage some of the younger generation to kind of get involved with this. And then when he found out more about what Eric's presentation was going to be about, the power of ether as related to music and electricity, then he opened it up for a couple people who were involved with music, which he was originally hoping to offer it up to some musical students. And surprisingly, when we ran that contest, we didn't really hear from musical students. We heard from a lot of talented people. But eventually, when everything was said and done, I passed it by Charles Berry, who is helping Eric out. He's a classical musical composer from Seattle, to have it run by him, and I sent it back to the anonymous donor to have him kind of look over it. And so we have Jason and Ross were selected as the ones that he would cover the conference and lodging for these guys. And what I want to do is just have each one take just 1 minute, give me your name, where you're from, a little bit about your background, why you're here, who you're here to see, and give an opportunity to give thanks to the anonymous donor who helped make it possible for you guys.
So my name is Jason Poteet. I'm from Central California area around Sacramento. And I would like to thank the Eric Dollard fan club for bringing me here, because I was, especially because as I entered the contest, I'd been unemployed for 9 months. Thankfully, I have a job now, but I didn't think I'd make it back. This is my second year, so I'm here to hear everybody. But my background is, I have studied music, studied organ. I have a small pipe organ in my dining room, not the best acoustical space for it, but that came from the university I attended. So I disassembled, reassembled it, and I tuned it. Thanks to Eric, I started getting into a little bit of studying historical tunings recently, and really got me interested in playing again a lot more. I've been a church musician as well too, but I tuned one rank of the organ to some Baroque tuning, and playing with that. I love all things that resonate, electrical and musical too, in the physical world. So look forward to talking to everybody that is interested in those things. I'm looking forward to the talk tomorrow too.
Hi, my name is Robert Davis. I'm from Canada, recently from Alberta. Really, it's just an honor just to meet all of you people and to be around such revolutionaries and pioneers of the free energy movement. And I'm just so grateful that I'm here and that I was able to be picked for this. I'm so grateful, and thank you so much from the anonymous donor. And yeah, I recently got accepted into SATE for electrical engineering technologist, and I'm hoping to bring this knowledge and be a pioneer myself in the future and help bring this movement even forward. So thank you.
Hi, my name is Josh Vetter. I'm from Bismarck, North Dakota, and I am an electrical engineering student at North Dakota State University, and I have one more semester left. I want to thank the anonymous donor for bringing me here. This is a great honor, especially meeting all you guys. For the last couple of years, I've been doing a lot of just private research in electric motors and batteries. I built a lot of small electric vehicles that I like to test out different arrangements and different fundamentals with the motors and, you know, driving the motors and stuff like that. So I've been working a lot with Bedini's battery charging and looking at some of Jim Moray and Paul Babcock's work. So it's very awesome. So just wanted to thank you all again for having me here. It's an honor.
My name is Ross Barable. I'm from southern Colorado, a little town called Pagosa Springs, and thank you very much to the Eric Dollard Fan Club for the scholarship to come and attend this event. This is my first year. I've been following this movement for about 4 years, and what I do is I've had a love affair with a folk harp for about 30 years, and I build the harp and I play the harp, and that transformed itself into designing and building outdoor acoustic sculptures in the form of wind harps. And the principle that I found a resonance with in building these instruments and listening to the speakers in this conference so far is energy resonance. And that seems to me to be the common thread that all of these electrical generating units have that allows them to really create a lot of power efficiently. In reflection on building wind harps, the first wind harps that I built usually had 48 strings, and now they have 18 strings, and that harvesting of that energy is all about resonance and finding the right geometry that resonates with the resonance of the frequencies that we're harvesting from the wind. So it's wonderful to be part of this and see the collaboration that's going on, and I am so grateful to be here. Thank you very much. My website that shows these different sonic geometries that I build is soundscapesinternational.com. So you'll have fun looking at these different harps, and they're all built out of titanium. So that's why I was interested in working with Brown's gas and changing the molecular configuration of those metals.
So hello everyone, my name is Anas Abdul-Rahim. I feel extremely out of place introducing myself in the midst of all these pioneers. I'm just a humble student. I study nuclear engineering. I'm from Toronto, Canada. I'm currently in my 4th year. I got interested in plasma, and it's quite interesting for a scatterbrain since it is quite dynamic. And I've been doing research with my professor. I'm a research assistant. I've done looked into the things like hot fusion, plasma gasification, and other plasma diagnostics. I first got into the alternate energy field when I watched Professor Eric's lecture of anti-relativity. I kind of felt like I was wearing an uninsulated lightning rod cap on the tip of a mountain. Glad I got him laughing. But yeah, it was a great experience. Watching the lecture is quite inspiring, and I really am. I'm shaking right now because it's nerve-wracking again. But yeah, it's a great experience, and I'm quite honored to meet so many like-minded people. And definitely, I really do appreciate the opportunity that the donors given us. I've got the opportunity to meet all these great winners that I have the honor of sharing the prize with, and yeah, I'm looking forward to everyone to the final series of lectures, and yeah, that's it about me.
My name is Dejan Stojanovic. I'm coming from Ontario, Canada. I did my undergrad in mathematical physics, and right now I'm doing my master's in high-frequency electromagnetics. About 2 years ago, I stumbled across Eric Dollard's work. I don't even know how. But I've been hooked ever since, and recently I've done some minor research in Tesla coils and their applications to communications. And I just want to thank everyone for being here. It's kind of surreal meeting these people that I just see on YouTube videos, but and I just want to thank everyone for making this possible.
Okay, now before we get started, I just have one one thing I wanted to mention here. If you've seen this little device with the LEDs on here, Michael Snyder of Revolution Labs was kind enough to just send me one to kind of demo and for people to play with. This will be in the back of the room. This glass disc in the middle is filled with like a ferrofluid, so he calls it a ferrofluid cell. I think he makes it on a 3D printer. And around is an array of LEDs of different colors. And when you put when it's plugged in and you put a magnet underneath, it kind of aligns the ferrous material in the liquid, and with the light, it gives real interesting effects. There's a bunch of pictures on the back of the kind of designs you can see that the magnetic fields are creating. And so his website is revolution-labs.com if you want to check it out. Kind of be a pretty cool little gift for kids and stuff, and let them play with magnets and see what's going on. And so anyway, I just wanted to thank Michael Snyder for sending that, and so check out his website if you want. We're going to get started with the panel discussion. We have, obviously, John Polakowski wasn't able to make it, and so he's not going to be with us. And John Bedini is not able to join us because he has other contract arrangements, so we can't really film certain things with him. I don't know if you guys want to maybe pull back on the table. Are you guys, everybody over here, okay if their backs are to you? Or okay, so Jeane has a mic. We have this mic. We'll pass between the speakers. There's a little podium thing over here with a microphone on it. And so when we open up for questions, and we have Jeane Manning with us, who has breakthrough power in the back. And we've been fortunate enough to have Jeane join us at all the previous conferences. And last year, she had an idea about the panel discussion, and we got a lot of really great feedback from it. And some people said that was actually their favorite part of it, so they can kind of see, who everybody is, outside of, whatever technical, discovery or invention or whatever they happen to be involved in.
Okay, I've certainly enjoyed doing this. I must tell you, this will be my last year because the spirit is really willing, but the ears are weak. And it's not great to have a moderator that can't hear. So these gentlemen are going to help me this year, ear infection. But anyway, we'll do our best. And before we get started, I want to mention something that fits in with Paul Babcock had mentioned that when he and independently from Jim Moray had both independently come up with a toroid motor that was so similar, and that it seems to be happening elsewhere too, that people are tuning into some new energy or new electrical paradigm. And I've noticed that with people that I've talked to, even up in Canada, a couple of the researchers have told me about breakthroughs in winding coils and working in harmony with nature's laws. I'm going to tell you briefly about one of them because he's going to open source everything he's learned so far, and he's wound more than 500 coils and years of self-funded research. And his name is Anton Malner. I won't go into depth on it, but Paul Harris is here. Paul and Callie, would you stand up, Paul and Callie, had witnessed his motor, which he calls the U1 for Universal One. He's a Walter Russell fan. And did you bring your laptop? Okay, so if anybody wants to talk to him about that, there's somebody that's going to open source their knowledge, which is one of the themes of today, young people having such a determination that we're going to get this new energy science out and working for the people, that so many are determined to share their knowledge. It's not so easy when you've spent 30 years or something on it, or your family and your friends have invested in other investors, then you're beholden to them. But it's easy for the young guys that I meet at the Global New Energy Movement to say that they'll give it all away, and they really are sincere. Introduce our panel briefly, starting over at our resident electrical genius, Eric Dollard. And Al Throckmorton, I've met at conferences going way back to the 1990s. Really enjoyed hearing Graham Gunderson today. First time I've heard him at one of these conferences, and what an excellent speaker. And everybody knows Aaron Murakami, our organizer here. Jim Murray, just heard his electrical genius in his talk. And working now with Paul Babcock. How many years ago was you met here? Just a couple of years ago or 3 years ago?
Yeah, it was the second conference, so this is the fourth, yeah. So we've been working together for basically 2 years now.
Yeah, what synergy. Two brilliant people that are putting together what they know. And William Lyne, I really liked that you talked about the natural philosophers of the 1900s, because I was raised kind of like they were, where you're wandering around the countryside and you're observing the forest, and I was hanging out beside the creek, and so they were learning from nature, right? And I wonder if our generation of addicted to electronics that you check every 15 minutes really gets that much quiet contemplation time in nature. I hope so, because that's what it seems to take for the real breakthroughs is people who do have some silent time where they can tune in. And at the end, Doug Lindstrom, hadn't heard your theoretical work, but I'm glad that you can talk about LANR and other topics that we haven't usually covered, because it's a big field, this new energy scene, and there's so much variety here in the work that these people do. What I'm going to ask the panel to do is talk about common themes, which I decided I was going to do that, but actually you've already done a lot of talking about themes that you see, and each of you in your own fields. But for those that are maybe listening to this, haven't had the benefit of all these talks, maybe you can continue and sum up some of what you said. Let's just start right here with Aaron. I know you've written about what's common in the successful energy devices, and as opposed to those who were deluded or whatever. Would you be willing to start here?
Can everybody hear that okay? Okay. Starting off at looking at John Bedini's work when I first met him about 16 years ago, and then being introduced to some of Peter's work and looking at Tom Bearden's stuff, and took me a long time to start looking at Eric Dollard's stuff because I didn't comprehend anything about it, but little by little by little started to see that there's like a common thread through a lot of them. Paul Babcock mentions these algebraic inequalities where one thing doesn't equal another. You have this, if you have a certain input and you have a little bit more output, obviously that's an inequality. So, what's going on? The work of Tom Bearden, I guess, a lot of it is kind of controversial and stuff, but one of the principles that I learned from him that I agree with is a lot of people are familiar with the concept of open systems or non-equilibrium systems because of a lot of the analogies he put out. And so if you just look at what's common between a lot of the devices, are that they're not closed loop systems that are constantly being talked about and said, well, it's impossible to do this or that. But it is when you're operating outside of those parameters, and when you understand the principles of the open systems, where it's not more is going out of the machine than going in, more is going out than what you have to put in. So obviously that means that there's extra input from somewhere. So, is it from a permanent magnet? Is it, directly from the ether, or is it heat, or is it sunshine? Is it wind? Whatever it happens to be, there is going to be an extra input somewhere, but that's input you don't really have to pay for. So you're just putting a little bit in, you're able to leverage nature in a way to where it can come in and contribute. And so looking at different machines and different claims and stuff like that, automatically you can see if certain things are not, I don't want to use the word conform, but if certain devices don't conform to those principles that we know will give these effects, most likely it's fake, or they're not, or the person who is doing it doesn't really understand it. But I see that as like a common theme between everything I've ever seen that actually does work and do what's claimed, like some of the devices and machines that were explained this weekend. And I don't see any deviation from that, but that's just one example of like a continuity that I see between all of these. And everybody might have a different way how they're going to explain it, but I see it's the same. So.
Okay, great. I'm going to switch over this side now. And Graham, you've investigated a lot of different machines, but you've also looked at the history too, haven't you, of this field, and any common themes in the big picture of what may be tapping into some non-explained energy?
Isn't that a heck of a question?
Yeah, sorry about that.
You know, when you ask me that, I get two things on the personal level. The first thing that I know of inventors who tend to be successful here is that it really, it's a marriage of sorts. It's a lifelong commitment. You don't do this in 2 years. Maybe there are those who do. I don't know of any off the top of my head. There's a learning process that takes a very long time, and it seems in order to do it well, just for example, I talked about this Floyd Sweet guy. The guy could have given it away. He was in his 80s. Why didn't he give it away? You know, either it was fake or he was selfish or, you know, who knows? And at a certain point, who cares? It takes a lifetime. It takes a very long time. Floyd Sweet accumulated the knowledge. I think pretty much everybody sitting here and maybe those in the audience, there's a large investment of time, blood, sweat, tears. The second depressing thing that I have to say is it has a tendency to really screw up a person's finances.
That's the understatement.
It's almost a truism. But look at Columbus. This guy left his homeland and people he presumably loved for years. People that changed the world put their lives on the line to do so. There's an element of a lot of these technologies that I think penetrates a Faraday cage. One of the things that I'm interested in doing is putting sensors inside of a Faraday cage to see what penetrates that, because things do, and those tend to be fields that don't fit into the Maxwellian picture, which is really the heavy side picture, I think it's fair to say.
Any ideas on how to detect those fields?
Yes. Tom Bearden wrote about one where he took a powerful magnet, just put a coil on it. One of the things that John Bedini said is that when gravity changes, it changes the substrate in which our fields operate, right? So the coupling of a coil and a magnet normally doesn't induce anything because there's no change. If gravity changes, then it changes that coupling, so presumably we can get something out of it. Another thing that I found pretty interesting is if we use a piezo crystal, and by piezo like barium titanate or PZT, lead zirconium titanate. And this again is a perovskite or a spinel structure that is highly stressed. Right? There's a little titanium atom or a lead atom or however it all works out, but it's pulled to one end of this crystal. It's pulled, so it's under a lot of stress in there. And it seems to be that when the ether weather changes, if we're going to call it that, that the potential in the crystal changes a little bit. Now, this is difficult to do because they use piezos for microphones. Any slight vibration will show up, right? So the crystal has to be suspended. It needs to be fed into an amplifier. It has effectively infinite impedance. There's some caveats to getting to work well, but at the end of the day, the piezo ends up listening to something that is not acoustic. It's ether acoustic, like Tesla was talking about, not so much gaseous acoustic. So that's one of the things that can be looked into. And at the end of the day, I have had some luck just with, in like a paint can, putting an electrode that was between two grounded electrodes but not equally spaced, that went into a FET amplifier that was magnified by a factor of something like 10 million. And if I pulse a bifilar coil, again, that emanation that has unusual properties, I can hear it inside the paint can. I can shield that thing with all kinds of layers of this and that, and something comes out of that amplifier. Also from old-fashioned CRT TVs, when I modulate the cathode current, there's something that comes off the front of the tube that gets through a Faraday cage. And if it's amplified enough, I can hear the modulation of the cathode. and it goes right through the metal shield.
The people who are called ergonomists say that whatever comes off the cathode ray tube is biologically harmful. Is that?
It's harmful in all respects, if you want to ask me.
That radiation is harmful to the life force energy that they call the orgone in the atmosphere. I don't know if anybody on this panel has studied those concepts of Wilhelm Reich, but that really concerns me now that we have nuclear accidents and strange weather. I don't know. If anybody can comment on that, that's great.
How about you, Al?
Those that have heard me speak know that I am a creationist. And I look out there at the heavenlies, and you can look as far as you want it. And I have a smartphone in my pocket. There's no question about somebody built that smartphone. And I'm a stupid man if I think that this looking out there at the cosmos, that it's a random thing. No, it's intelligent design. It's been built. All right. So, coming from that viewpoint, and I see it happening here more and more, that people are trying to explain the creation. And if you're looking at it from his point of view, he wants you, you see, to explain the creation. And explaining the creation elevates us and serves us, because we have people here who are working in areas that are a benefit to you and I. And it takes us a long time to get to the point to know what is of benefit to each one of us. We're fortunate that Industrial Research Magazine at one time did a study of the 100 most significant inventions. And they set up a criteria which is subjective and you can argue with, but they came up with 100. Of those 100, 97 were invented by individuals. Now, I spent time working for Hewlett-Packard, and we have brilliant engineers, and they file patents or ideas which are absurd economically, because I'm an economist, you see, and they wind up being of no value. Tremendous technical achievement, brilliant minds, but the thing that they were inventing was worth nothing. Worth nothing? They spent a lot of time, and but you see, they picked, well, what's of interest was not the 100 that they picked, but the data. You know, the median age, 97 out of the 100 were invented by individuals. The median age was 70. And in line with what you said, it takes a while. You see? And there's hope for me, because the median age was 70. That meant there were a lot of people way over 70. That's right. And some of these patents were granted when the men were 90, 80. Finally figured out what it is that serves you and me. Because you and I set the value. When I go in the store, I'm not going to buy that bread. You see, I set the price. Don't think that you're being controlled. You set the price. Because you can walk away. You see? And you're setting the value. As an economist, it's It's a long story about the free market and all this kind of stuff, you see?
Yeah, don't have time for long stories.
No. So I will stop and say, you see, that you heard me talk about the law of originality. There are no two people here in this room alike. There are no two Earths in the entire universe. You can look forever, you'll never find it. And there's one place right here, right now, where people are born. And there are people not being born on Mars. They're not being born on the galaxies at the backside of the universe that the Hubble just looked at. It's right here. And the thing that I see jointly is now people investigating the creation and starting to see how it works, and then interpreting it that brings it to the value of you and I, the most value. And I see that happening more and more. You, sir, and Jim Murray spent a whole time going over and presenting this product. You see, what is it? It's something that can serve you and I better tomorrow than yesterday. And we're on the cutting edge of looking at the creation, seeing how it works. How can I do something to bring that to us? Not a smart rock, you see, but a piece of equipment and gear, which is going to be incorporated when the economic becomes an economic viability. And I see this phase change because I've been at this since 1984. We're now working on things that are of real value.
Okay, well, I'm kind of stuck in a weird position right now of transitioning between digging holes for utility poles at Death Valley and all of a sudden having to explain the formation of the universe.
Yeah, there you go.
And transitioning from a pharaoh life into the core of Babylon at 105 decibels. So, and my aversion, the romanticism, I can't really say anything that's going to make you feel all groovy. But the emphasis of my presentation is going to is focused on transcending beyond energy. The only reason that there's any interest in electricity at all is its energetic equivalence to gold. And otherwise, I think as he explained with the HP people, it's destined for the dumpster. So at any rate, I'll cough up the whole thing tomorrow. I mean, I was working on it right up to the point I came here. This is not going to be 10 pounds of shit in a 5-pound bag. It's going to be a ton of it.
That's great. Okay. Jim Murray next.
The theme you wanted to explain to Jim?
Well, Jim, I know you've been in this field longer than practically anybody, and all the way studying Tesla, Otis Carr, all these people all the way through. And do you see common threads in the themes of what people were beginning to understand there? Do you see a progression into now?
Well, as far as common threads go, anybody who listened to my first lecture 3 years ago would realize that I've been animated for many years with a driving force to find answers to highly technical issues that have been ignored by the average individual and primarily by the scientific establishment. And so when I first started out, I was 19 years old. And I had a pretty classical education in physics and mathematics. And despite the comfort that I had in the expression of that education for the pursuit of normal things, I was left with a really unsettling feeling that I didn't know a damn thing. And so I spent a great many years tracking down individuals that I felt had done something of interest that I might benefit from, at least in terms of learning. And as Jeane said, that embodied all kinds of characters. Otis Carr, Gene Carini, Dominic Lucchesi, Getz, and hundreds of other people. And there's all kinds of common threads that we could expound upon from the technological point of view. But what I eventually came to understand about each of these people and others that I didn't mention was that there is a much more profound common thread, which is not technical in nature, but it's kind of spiritual in nature. And what that really embodies is the fact that in our everyday lives, we seemingly have two choices as to how we can proceed through our destiny. We can kind of immerse ourselves in the everyday activities that everybody does and, you know, entertain ourselves from time to time and keep a steady job and do all the things that everybody else does and eventually wind up in a nice shiny coffin. But there's also another route, and that is that you can say, yeah, all of that's great, even though it's kind of mediocre. I would like to do something a little bit different. How do you do that? And what it turns out is that you have to find quiet time, as you talked about. You have to isolate yourself from the cares and woes of the world and meditate, as it were, on a specific goal. And then you fill yourself with wonder and admiration about how that goal might be achieved. And you literally allow that emotion and that intent to erupt from your person and swell into the universe with the interesting and very definite desire to hear an answer. And eventually you do. And it is the cultivation of that type of interaction with the universe that starts to precipitate what we call inspiration, true inspiration. I don't mean building a different birdhouse or a better mousetrap. I'm talking about something that you never thought of, and that when it does come to you, you recognize it as a gift from beyond yourself. And once that occurs, all I can tell you is you're smitten. There's no way out. If you didn't have the intention of making that your life's work, whether you like it or not, you're involved in a contract. And once you have a gift of that sort, I truly believe that it is an obligation on the behalf of the person who receives such inspiration to make something good of it and to do something worthwhile with it. Sure, you can go out and sell it and some corporation will put it on the shelf for the next 20 years, but that's not what it was given to you for. And so my journey has been one which is certainly possessed of two different thrusts. I've done my best to educate myself outside the box from the technological point of view, and simultaneously I've done my best to cultivate a one-on-one relationship with some higher entity, whatever it may be. And I've done all of that with the intention of making this unbelievable pigsty into something far better than it is today. And so the only advice I can give you is that this particular bifilar process has worked for me, and I don't think I'm that different from many of you guys and ladies. So if this turns out to be a goal you want to pursue, imitate success. It really works.
Well, as much as I appreciate Eric's grim and dire view of life in Babylon, the grimness and direness to me makes it all so much more fun. Because there's really, life is a lot more than, we're all a lot more than we think we are. And the common thread that really runs through this whole thing runs through each and every one of us. You wouldn't be here. There's no such thing as coincidence. You've all been led here. And we're on a journey together that to me is the most, there ain't no roller coaster on the planet that's as fun as this one. It's been painful, it's been bloody. I can tell story after story. But at the same time, the fight couldn't be more fun. So that's how I kind of look at it. We're here to do two things. We're here to learn, and we're here to have fun, and we're here to transform Babylon. And we might completely fail at that. And, well, if we fail, we fail. To me, we'll get our other chance. Who knows, maybe 40 centuries from now. But right now, the fun is on. And it gets more fun, it's logarithmic. It really is. And so, the joy I take in defeating the Babylonites, or whatever you want to call them, the feeling I get from bringing knowledge into the world and defeating the monopolists, transforming the world, taking it away from the few. To me, the real question of the age is, are the few going to control the many, or are the many going to control the few? Me, I want every human being to have whatever canvas he needs to reach his full potential, which means access to resources, access to energy, access to nature, access to your psychic self, all those things we have. And our civilization operates within a very narrow parameter of what we really have. And so using all of our tools, it's like there's this psychic thing that's going on amongst all humanity right now. And if you're a human being living on planet Earth, you have to feel it. There is a vibration on. The music is changing. Things are happening right now that probably haven't happened in 50,000 years, since the other civilizations that blew themselves up are gone. Maybe it's all incarnation and we're just repeating, trying to make it work this time around. But whatever it is fun. I cannot tell you, like Jim was talking about earlier, where this stuff comes from. I mean, it just doesn't, it's just not random. I mean, it's when we connect, and it's not just electricity and new energy, it's everything. It's spiritual knowledge, it's scientific knowledge. It's there in this big library somewhere, and our job is to download that stuff and transform our world to the way we want it to be, because we are the reality creators. We create reality. Reality does not create us. And that's what I've learned in life. To me, fall in the trap of self-pity, and my world transforms into this ugliness. Selfishness, whatever it is, my world suddenly transforms into bad luck or no luck at all, and bad events. But when I take on a different attitude and open up different doorways, my world translates into this thing of beauty, this thing of challenge, this thing of fun, especially the fun. I just can't tell you how much fun I have in this life. So my thing is, and this is what like I tried to talk with my two lectures, when we change internally, when we change our beliefs, when we see the world in a different way as individuals, en masse, this world will just transform upon itself. And that's really my message is, let's change ourselves, take advantage of this library that we have, learn to look at the world in a little different way, look at ourselves in a little different way. to see how really good human beings really are and to win this game, to transform it the way we want it. Personal freedom is everything. Human rights are one thing, but nothing supersedes individual rights. And the fact that I am here means that I am valid and I have a right to be here. And everybody who breathes can say the same thing. And so when we learn to quit arguing with each other, transform, work our energy together, we will transform this world and Tesla will have his century.
What? Yes. Yes. Well, I think there's a common thread here. And I think I see my mission, you know, I'm kind of like Don Quixote, you know, charging the windmills of status quo. But I don't want to end up like Miguel Quijana, you know. I want to see some success somewhere before the end of the line. I think of the creative process as very important. I think the fundamental means of survival for the human race of man qua man. The first guy that took a rock, I say guy, it might have been a lady that hooked a rock to a stick and made a hatchet, could chop down trees. You know, that was the early inventive process. And you might invent something and find out that there's 1,000 versions of it already invented somewhere. But so that I think is, I conceive of that as sort of my mission to spread the creative process. Being here this time, I've kind of been inspired to, well, how about writing a little book on the creative process for inventors? Because, you know, it didn't occur to me first when I started inventing things when I was a little kid. I didn't think about the creative process. I was just busy doing things. And but as the time went on, I began to look at things, and my main education was in art, and I don't consider most people think of the arts as being highly creative. Well, most of it is not creative, not very creative. It's mostly somebody hacking out something that there's dozens of them just like it, you know. It's not a lot of creativity involved. There are only a handful of people in the arts that are really major creative people. There's more creativity probably in the mechanical and physical sciences, that sort of thing. The creative process is I've heard it described as a bisociation of two previously unrelated matrices on the preconscious level. So it's right on the edge of consciousness that this occurs. And that's the creative event, the big light bulb that comes on. But it's not like there's no John Philip Sousa marching band going to start up, you know, when that happens. It could be start out as something small, and then you begin to piece it together gradually. But when something grabs hold of you, you just are just drawn into it, and you pursue it, you know. It's like I got into the hydrogen thing, and it kind of took over, you know. I got into metals processing one time, and it just involved years and years of just, I never took a chemistry course. And I was just spending years and years of doing this wet chemistry thing with separating these metals and so forth. And finally I got burned out on it, so all those metals are all sitting in a pile, you know, all the precipitates and so forth, you know. I think maybe someday I'll go back and clean them all up and maybe, but anyway, that's the way the creative process really works. I don't agree with Thomas Edison that it's 9/10 perspiration, but that's pretty close. But I like Tesla's idea. You know, he basically would envision these things and in full force. You know, he saw them complete. It was very extraordinary in that respect. But you know, he really was involved in the creative process. But I see this group as a stimulus in our society of creativity. I mean, we just can't take things the way they are. We can see that they're rotten, that we're being torqued around by energy cartels and medical cartels, and everything seems to be a cartel, that's trying to twist you around and make you bend to its will. And so I think, we should just open the door and start looking at alternatives. There's more creativity happening in the medical sciences, in curing cancer and that sort of thing. And eventually the chemical company or the pharmaceutical companies will claim it's theirs and they'll have a patent on it, but who knows where they are going to get it, when it happens. But anyway, I really am really honored to be here, and I think that this really performs a great function to stimulate the creativity of inventors and just people that are looking for answers. I think that's what everyone here is for, is to try to get answers to questions and not rest on the answers they already have. All right, thank you.
It's really, really hard to follow a bunch of eloquent speakers like you guys. I could, talking about common themes, I could talk about resonances, and that you've heard just about everybody talk. I could talk about step functions and spikes that you've seen in a lot of presentations. But I think more of a common theme, if you look across the table up here, is the fact that we're getting less and less hair. It's getting grayer, our skins are wrinkling, except for the three in the middle. And so what really makes me glad is to see all the young people that have showed up and are showing interest in this weirdo bunch. And I give thanks to you guys up front here, too, for sharing all your stuff and starting to download this stuff to the young people that have to pick it up and run. Because we're not going to be around all that much longer.
Speak for yourself.
I guess it's a matter of what longer is, yeah. What can I say? I'm very honored that Aaron invited me to come down and talk. I didn't know what I was getting into. The last time I was to one of these was Hal Fox down in Idaho, I don't know, or in Salt Lake City about 12, 13, 14 years ago. I don't know if he's even alive anymore, is he? Hal Fox? I know he's not. No. You guys are just as weird as you were then. I think this is absolutely wonderful. I thought I was out of mainstream when I was not allowed to speak in Salt Lake City last year, and then I was invited to go to a conference last November in Baltimore and speak. I thought it was a fairly weird bunch. I couldn't go because I was a little bit too off mainstream, I guess. They said, well, you can come and present if you spell your name backwards on your paper, then we might be able to present it. So I looked at my name, it was Salgud Mortsnil. And I didn't think I wanted to be handled with that, so I stayed away from that conference. You guys make me seem mainstream, and I feel really good about it. Thank you so much.
How you guys doing? Nice to see the group, and I feel like the dummy in the room, but I know I'm not because I'm here. Can you hear me? My question is for a person that's not a highly educated person and they want to get into the alternative energies itself for creating power, where would you start?
Could you all hear that, Mike?
Is your question to any certain person?
No, anybody that can give me a good answer.
Okay. And would you repeat that once more, please?
For a person that's not a highly educated person and they want to get in the alternative energy for creating power, where would you recommend they start?
Good question. Who would like to tackle that first?
I'll take it.
Jim.
Wow. To be real honest with you, looking back on my own history, I had that inclination when I was 18, 19 years old, and it occurred to me then that the most intelligent step to take is to understand conventional stuff and use that as a stepping stone. So if you really want to get into something alternative, start investigating all the sources of power that are already well known, and that will teach you unbelievably.
Well, I work with fuel cell technology. I mean, I've been around electronics. I'm a professional mechanic. I've been around the block on quite a bit of the stuff. I see the complications of some of the, electrical you get into, and you get into diodes and transistors and so on and so forth, which is a little over my head. I'm working with some of the mechanical aspects of power generation, but not sure where to go from here.
Well, in that case, if you wanted to do something unique, try the meditation process. And you'll get an inspiration and then just jump on it. I'm serious.
Yep. I understand that. Perfect, thank you.
I'd like to add something to that. I don't have a whole lot of education. I got a 2-year degree from DeVry. And that gave me the basics. But life teaches you. But the other thing is just because you don't know electronics doesn't mean you shouldn't start blowing things up. If you're not letting smoke out of something and letting the spirit out of it, you're not working at it hard enough.
Well, I caught something earlier you'd mentioned, and you talked about whether or not you win or fail. The only way we can fail is not to try.
Well said.
Can I address that?
Graham's got something here.
Yeah, I can do Paul one better. I have like 0 education. I didn't even get out of high school. It's been said that all of us contain a native genius, and maybe there's some validity in saying you locate what lights you up. And don't worry about understanding it or not. Some guy out in the audience asked me if I understand this or that kind of geometry. And I tried to find a polite way of saying it doesn't matter. I'll read the paper as if I understand it, and if I read it about 17 times, I end up understanding some of it. I think Jim raises a very good point that you can have the stepping stone of knowing where others have stepped, because otherwise you'll step in it, right? So we get to kind of reinvent the wheel, and we have limited time here on this earth, and that's maybe not the most productive thing. So it's a good thing to go. There's some books. There's The Art of Electronics by Horowitz and Hill. You get to the last page of that one, diodes won't be a mystery anymore. You'll master that. It's one of the best, very readable, engaging books that there is to understand the circuit stuff. As far as electricity and magnetism, maybe we can put together a list, but there are some good resources out there. I think Jim has done a lot of digging around and finding even some of the advanced resources. And one of the best things I've ever found is don't worry about if I understand it or not. Just barge on in. Be unqualified. Be that weird guy in the biker bar and every head turns. And just do it. But find what makes you passionate, and like Paul said, blow stuff up. Don't worry about it. But like, don't spend all your money. Like if you're married or whatever, like still go out with your wife. Like, don't go crazy. I can attest to that because I've screwed that one up. Like, be a little bit balanced, but just go for it, man.
You mean that $300,000 I've already invested?
Yeah, that.
Right. Yeah, I got something to say. So again, romanticism aside, you're going to have to go back to the beginning and just chuck everything that you get out of the universities or libraries today. All the good books have been pulled off the library shelves, and the ones that didn't fly in the dumpster are available on eBay or whatever. And you're going to have to go back to the beginning. You're going to have to go back and understand Faraday. You're going to have to read all of his experimental researches. You're going to have to learn about Maxwell. You're going to have to learn about J.J. Thomson. You're going to have to learn about Heaviside. You're going to have to try to extract what little information that Tesla leaked out about he was doing. The best way to gain the proper entry into electrical engineering is to use Steinmetz as the basis of your process. And then when you want to get back into the spiritual side that's been all erased, you're going to have to go all the way back to Pythagoras and understand how all this stuff came about thousands of years ago. And there's basically nothing new in any of this. Now, as far as energy and electricity goes, electronics has no relation to that. So electronics is based on theories from quantum physics and all these things, and all that will just confuse your mind because there's not any real knowledge there. So the best you can be with regard to electronics is a technician, and if you want to be an excellent electronics technician, I would do everything possible to find and apply to yourself the Navy 2-year program on electronics, preferably an older one from my day in the 70s, and then be ready to spend 12 years on it. That's all I have to say about that.
Well, to give you a little of my background so you know where I'm from, I'm a certified master technician, the highest level that you can get with Chrysler Corporation. So electronics isn't something new, but it's applied differently here than I am with the cars. Do you see where there's a similarity of what I can use from my already have in knowledge?
I didn't quite get the last part of the question.
Hold the microphone a little closer.
With my experience with the cars, being a computer geek on cars, with the knowledge that I already have on electronics and how electrical systems work, is there a way to transform that to what we're working with here now?
You're talking about automobiles? Uh-huh. Well, the concentration is on the motor and the supply of energy, not the electronics that controls it.
Right, so you're talking about the load and the...
Well, I'm talking about the magnetic fields, the development of EMF, of the way that the electromotive force is derived from the intermolecular energies inside the battery, the possible appearance of intraatomic energy, as was suggested by Dr. Lindemann, which actually atomic power is much more widespread in nature than the Einsteinians and the rest of them would you have you believe. And the notions of Tesla, where his belief that radioactivity was from external causes, and there's so many conflicting theories and fighting through all this stuff. I mean, I really don't know what to expect. I was fortunate that I started when I was 6 years old. And I had all the, the old-timers that knew all this stuff, and everything worked back then. There was no computers. You didn't need that stuff. The telephone in the house rang once a week, if you could imagine such a thing. People had other things to do in their lives other than peck their device like poultry. And you just have to go back to that world. That's, you're going to have to go backwards in time. You're going to have to hit the reset button. The electronics is just the intermediary between the electrical process. Electronics destroys electricity. That's how it functions.
Thank you guys for all your help.
I'd like to make a simple comment on this as to how to proceed. And my theory is that you have to study the classics to learn the mistakes. And available on the internet now, there's the full electronics and mathematics courses of MIT are available. So there's a 40-hour course with laboratory demonstrations and problem sets with answers and things of that sort that are available free. I think look under MIT, and it's like electronics, I don't know, 101 or something like that. And I'd say that's a fairly accessible way to start with this foundation.
Do you have a question?
Well, yeah, if I go on with, I have two questions, actually, if I have the time. Okay, as I get older and more brittle, thinking of health issues, and this group has inspired me in a way. You know, we have piezoelectricity, which, as I understand it, you can take a voltage and create movement that can create sound, and you can run it backwards, too, and have sound create a voltage. There's another phenomenon called triboluminescence, in which by breaking crystals, you can create light. I don't know if you've ever seen it. It's a remarkable kind of color, and I have some experience in some really exotic materials, but the most common one would be sugar. That will break if you ever go to a big factory. You can see the light coming off. So I'm wondering if there's anyone, maybe an incarnation of Marcel Vogel or whatever, that knows about this for healing bones using this kind of light, kind of run backwards. If you can break something to make light, can you use this light to facilitate healing? Anyway, that's my crazy idea. Okay.
Do you have an answer?
I experienced that in 1980. I was just a recent graduate from Rutgers University. I was working part-time at United Parcel Service at night.
I can mention something.
I was waiting to get married 2 weeks after graduation, and a drunk driver T-boned my car as I was getting off at 2:30 in the morning. And so left tib and fib were both crushed an inch below the knee. After having extensive bone grafting and all of all the shards that were left, the surgeon put on a electromagnetic bone growth stimulator, which basically looked like two shoulder pads that you might use on a football team, but they had big coils. And I had to sit on a machine which was basically pulsing these coils for about 4 hours a day to stimulate the bone growth. He chose that device because the electrostatic stimulation devices meant you had to puncture again the skin. And that was going to give you more of a infection problem. And so he thought the electromagnetic was actually effective in the bone growth stimulation. And while today all the bones still have the remnants of the shards being there, it actually did firm up into a big solid mass, so the bone is there.
Great, so that exists. That's inspirational.
I have an answer for you.
I have a second kind of question.
Can I comment on that?
Yeah, please.
Yeah, and it can be even a lot simpler than that. I was mentored by the first and only non-Chinese certified Qigong master in the world, who was certified by the Chinese Qigong delegation in Beijing, and one of his partners was Dr. Charles McGee, who's an incredible medical researcher, and he's retired now, but we used to have a company that were manufacturing red light blankets. This was before light healing became popular, and you see all these LED devices for healing cuts and this kind of thing. Well, for one, just red and infrared light, what was found was Dr. McGee used to actually study from Dr. Paul Nogier in France, in Lyon, France, and he's known as the father of auricular therapy, which is the whole ear is a map of the body, you know, like a fetus. The earlobe is represents the eye, then you got the spine, and it kind of curves around. So if you stimulate the vision point on the earlobe, you can crawl up on a crow's nest, look out, and your vision is a little sharper. That's why they would, sailors and stuff would pierce their ears. So for example, what Nogier did was he would use magnetic fields, and he would put on different acupuncture points and different trigger points and different tissue types, for example, to see what frequency would give a strengthening response. He used a radial pulse near the wrist, and he would dial into the different frequencies to see what would strengthen. So he wrote all these frequencies down and found out that depending on the tissue type, it would resonate, it would give a strengthening response at different frequencies. For ectoderm tissue, skin, teeth, brains, eyes, all the outside, was 292 cycles a second. You double that, that will work on, I believe, mesoderm tissue, and then if you double that is for endoderm tissue. Okay, just simple red light. The other, and so if you just search for Nogier frequencies, N-O-G-E-I-E-R, I believe. It's a French name, Nogier. And so those are known as the Nogier tissue resonant frequencies that were used by holistic doctors and stuff. And but that can heal and stimulate the healing of bones. I mean, just red light by itself is 660 nanometers if you're right in the middle and you're blood cells are about the same, and so is chlorophyll. And if you look at the mitochondria, it's about 660 to 880 or so. So it's all in the 600, 800 nanometer range, which means, you know, all those cells in your body are pretty much tuned antennas, mostly for the red and blue light, or red and infrared light. But it works. I've seen things that, you know, a lot of people probably wouldn't believe, but very, very simple. A lot of the industry is ripping people off with super expensive devices, which are nothing more than glorified LED flashlights pulsing at frequencies that mean absolutely nothing. But those Nogier frequencies, Nogier didn't know it at the time, but later found out they were all harmonics of a musical D note on whatever scale. And so Nogier frequencies, find the one for the bone tissue, and you just set up a bank of red and infrared lights, put it in the area, put it on a function generator, and chop the power supply at the exact frequency, and you know, twice a day, 20, 30 minutes at a time, and you'll see an acceleration in that.
That's great. Okay, I have one other sort of question, because we talk about here that we live in this ocean of energy. Okay, with the photovoltaic technology, as I understand it, it's understood that at this distance from the sun, 1 square meter optimally could collect 1 kilowatt hour of energy, I believe, right? Okay. But we also talk about how these individual atomic cosmic rays are coming through. If you could somehow capture all of this flux coming through a square meter in an hour, even though it's, I don't know, millions of electron volts in a little one particle, whatever, meson, whatever, in effect, how much energy would that add up to be?
I can't speak of the actual quantity, but I can issue a warning. The thing is, energy's a dead-end street unless you want to turn the Earth into a fireball. That's the bottom line complication. So the energy that's here right now in this room could cause such a violent destruction that in a picosecond, everything could be raised to a temperature of 50,000 degrees or greater. And how this comes about is very simple. The Earth rotates at 1,000 miles an hour. Now, it flies around the sun at some even faster velocity. I can't remember right off the top of my head. The solar system is flying through space at an even faster speed. Now, when you throw a rock off of that train and it hits the ground, the blast is going to be inconceivable. So now if we start dragging on that and converting that into heat, which is the net result of all of this thermodynamic energy that we seem to be worshiping, the consequences will be dire. And as an example of how all this worked out, you know, and Tesla and Steinmetz and Edison and all them, they came from a time when the human population was very small, and they didn't really see in their minds that this was just going to escalate into a situation now where you can't even see the stars at night anymore. The firmament has disappeared because of the improper use of the electric light, which mainly is a mechanism of human paranoia to keep the evil spirits out of their house.
At 47 degrees north latitude up in Quebec, I see the stars at night.
No, you don't see the stars at night. The calculated quantity of visible stars in the era when you could see the firmament was 400 million. I remember this when I was a child, very young, that you'd go to places, and that's all there was the stars. There wasn't anything else. There wasn't your friend. There wasn't the ground you were standing on. There weren't the trees. There was nothing but the stars. Now, to prove my position on the matter, I live outside. Okay, I can wear out a set of tires in 6 months driving on thousands of miles of Jeep trails into the most remote, inconceivable areas. If anybody's in the passenger seat of my car, they're screaming in terror of what the ordeal is. There are no more stars. I can see my car, I can see myself, I can see the ground around me, I can see plainly at night anywhere where I am, even in the deepest wilderness.
So when I'm looking at Orion's belt or Sirius or Venus the other night, isn't that something like a star?
That is 0.01% of what used to be visible.
Hey, there's a patent from Nikola Tesla that I think maybe you're talking about, and it's like one of the simplest things he ever come up with. And it's a metal plate, and you said you had to put insulation on it. So these days you'd get like a bunch of really thick plexiglass. He said the better the insulation, the better this works. So he puts this big metal plate up high on a mast, somewhere up high like on your roof or whatever, and it's got to be completely insulated with thick, good insulation. So right, like you'd get a bunch of like inch thick plexiglass. Sometimes you go to like their metal shop over in Spokane somewhere, where these things are so crazy they'll break and all this stuff, and so you can get it really cheap because it's all just pieces that are irregular or whatever. Then you put that around a plate and you run high voltage cable out of it. You seen this stuff? It's like silicone cable. You can buy it on eBay. Type into eBay like 40 kV cable or whatnot, and it's a really thick wire, but it's all insulation because it's meant for 40,000 volts. It's got to be all insulation. So thin little conductor and this whole bunch of silicone. You run that down. Then Tesla's patent shows that you put this into a high voltage capacitor. Again, you can get that on eBay. It's pretty cheap. You can get 20 or 30 kilovolts. This insulated plate, from which electrons, evident by our laws, they can't enter or leave. It's insulated. But it's up on a mast somewhere, exposed to these cosmic rays. Something is happening, and that capacitor charges. Tesla had basically a vane switch across that capacitor, where the capacitor charges to some tens of kilovolts, and it causes the electrodes in this switch to attract, close the switch through a load in series with it. So call it a transformer primary. So you're going to get pulses of electricity. Like Eric, I can't tell you what to expect, but if Tesla patented it, there's probably good reason for why he patented it. It must be something. I've never built it, but if you want to build it, come back next year and tell me what it does.
I can give you some more details. Okay, now the important thing is you have to use a mica capacitor, but in Tesla's time. But I think some of the modern ceramic capacitors will work just as well. They don't have any leakage. One terminal has to be earthed. The other one is connected to the elevated electrode. It's very important that there be no surface barrier of any kind on the elevated electrode. It has to be highly polished, preferably amalgamated. That's a critical part of receiving these cosmic rays. Now, what Tesla did is when the capacitor became charged, it was discharged into a Tesla form of resonant transformer, which took the charge, converted it into magnetism, and then threw it back into the capacitor. One thing that's not realized about Tesla's technology is that it's mostly power-based and it's not energy-based, and all the energy is returned at the end of the cycle. And that's what Tesla was after with that technology. I've done some experiments in that, and once you get all the resonance right, where the capacitors on the load side of the transformer and the capacitor that's picking up the cosmic rays are synchronously dumping their energy into each other, you can get it to resonate, and you can actually get some significant voltages, steady significant voltages out of it, but it takes some pretty good skill in dealing with electrical switching and insulation and other things to do that. But it's fundamentally simple to do, and the patents pretty much illustrate it, and Tesla describes, you know, scattered throughout, if you read everything. I would suggest, if you really want to understand Tesla's ideas on things, is you get that book that came out of his homeland in 1956. I think it's called The Notes, Lectures, and Patents of Nikola Tesla. And cryptically and in a very distributed way, everything you need to know about this stuff is all pretty much weaved through there. One complication with Tesla is he starts to contradict himself later in life, and he seems more interested in fooling with people's minds and playing games with them in some kind of revenge for getting screwed in the rear end earlier, which is very understandable. But it's best to go back to his original patents and the lectures and what few notes there are that he took. The Colorado Springs notes also has some of this stuff in it. but it's very scant, and it's good to have a solid background in electrical engineering and technology to know all the little details. But I really encourage people to experiment with it. And on my, I don't know what you call it, I call it a channel on Energetic Form, I've come up with a number of experiments to try to tap that cosmic ray using phototubes and prior charging of the surfaces and all that. And no one's really taken it very far. The introduction of the process was to create an all-electric, non-electronic Geiger counter based on Tesla's principles, where each impulse of radiation that was received would ring a telephone bell. And somebody actually duplicated this, and I'm encouraging it to be made as kind of an educational product to help people understand the principles of tapping the Tesla cosmic ray. But unfortunately, none of my stuff seems to go anywhere. Out of all the entire population of the planet, there's only 2 people working on this, and they have to stave off an army of detractors and people that are trying to steal the ideas for nefarious purposes. So that's why I basically dropped out of that area. I pretty much dropped out of everything. So I'm more interested in digging utility pole holes and stringing wire and building stuff, which was my initial aim, and not in getting involved in a lot of theory. But at any rate, I think, as somebody was pointing out here, I think it was Jim Murray, is the theory end of it can become addicting, and then all of a sudden you're trapped. And in 12-year blocks, you figure out one thing or another until all of a sudden you find out your hair is gray and you have less teeth.
Next question.
I love that this panel is so passionate about helping the world, and I just want to thank all of you for that. And I'm really concerned with the world right now that we're burning 89 million to 90 million barrels of oil a day, plus all the coal. There's so many great ideas right in front of us right now. How can we help?
How can we help? I think probably every one of you have an answer to that, right?
Well, we are burning so much oil, and you hear about a lot of arguments and people saying, ban fracking. We can't really get rid of that overnight without having something to replace it with.
Exactly.
And solar and wind is not going to do it in present state very fast. I mean, and it's very expensive, and it's been estimated that it takes more energy to put up a solar farm than you actually get from it. By its lifetime, it hadn't even paid for itself. So, basically what we're hoping for and working for is something that will replace oil. And that's the reason I'm pursuing certain inventions, because I hate the oil industry. I grew up in it. I lived in an oil field. I lived in towns that the place stunk like a sewage, and it's that sulfurous gas. I've spent the night in some of my friends' houses. They had to keep the top window open so that the gas that accumulated in the environment could get out of the house and not asphyxiate everyone. And I know people in the oil industry, a lot of people. Many of the people in my family worked in the oil industry, and I know how the oil companies operate. When the Rockefellers would turn on the Arab oil and turn off the local oil, all these people had to be fired and lose their jobs and move and abandon their houses because the Rockefeller decided to bring cheap Arab crude in the country at one point, and maybe then he would decide not to do that. So then all of a sudden you'd have another oil boom. Miraculously, oil would appear out of nowhere. So, I don't appreciate that side of the oil industry. And a lot of these people they worship the oil company they work for, like, they don't realize they're getting screwed. They're not getting paid enough.
So what do we do?
Yes.
So we are about 18 minutes past. Phil, if you're okay with the camera, are you okay with time? And if everybody's okay, then we can continue.
Okay.
If everybody's okay, yeah. If you have to leave, go ahead. We'll just keep going until we can't. Or
I don't. Yes, yeah, you may have seen the press release, and if you haven't, the United States government in the background is paying attention to what we've been saying. The Navy announced about 3 months ago that it was converting seawater into jet fuel using electrolysis to break up the water and taking the carbon, the CO2, which is the great sink here on Earth. We think we're putting CO2 in the atmosphere. What controls how much CO2 is in the atmosphere is what the water is doing and the temperature of the water and how much CO2 it's dissolving, okay? It's the great CO2 sink. And we think we're burning oil and adding CO2. It's the relationship with the atmosphere and the temperature of the ocean is controlling how much CO2 there is in the atmosphere. And they're taking the CO2 out of the water, which is providing the carbon, disassociating the water, which gives them the hydrogen, and they form a long chain link, and they're creating jet fuel for the planes on the carrier. You see, on the carrier can go for months, but it's hindered by tenders that are carrying the oil, the jet fuel, to run the aircraft. And it's to deliver to the aircraft, it's over $100 a gallon. You see, because you've got to stop and pour it, you got to buy it, you got to put it in a tender, takes it to the carrier, it's got to be pumped in the carrier, and a jet's burning it up at thousands of gallons an hour, quickly. So the Navy is now converting all its ships to run on seawater.
What do we do?
Well, the point is, okay, that's a good question. Audi just announced, and you may have seen the press release, and it was public, that they are converting water into diesel fuel to run in their Audi vehicles. It is happening, and people are listening, and the change is now occurring. And it will be a water-run economy before too long. But it takes a while, and it takes economics, it takes capital resources, etc., to provide to start that change. But the change is occurring. All the Navy will be running on seawater by 2050.
All right, let me break it down for you, man. I'm going to stand up and do this, too, because I'm running out of blood sugar, I'm hungry, and I'm getting ornery. It's really simple, man. It's the dollar. I used to do this for a living. I was blessed by the Lord to do it. It's the only way I can explain it, because it was a gift, and it came from somewhere well beyond me. All the stuff on this table, I wouldn't have had a word to say, and I wouldn't be here if it weren't for that. So God bless people that brought this there. But it's all money. That all fell apart. Why? Because it all ran out of money. And I'm like, this ain't good news, right? And it's nothing that none of us don't know already. But I don't get to do this all day anymore. I don't get to invent like that. I haven't come up with much new in the last year or two, and it's killing my heart, because this is what I want to do with my life, and I don't get to do it anymore. And I'm blessed to have an awesome job, and I work with awesome people. And if I ever have to go anywhere else, I'm going to miss them all. That kind of stinks too. But the way that, you know, if you're not making the smoke come out of transistors and that ain't your game or whatever, I mean, Jim, this guy, I'm blown away. This is one of the brightest people I think I've ever met in my life. Your speech today blew me away. It was amazing. And he made the comment that he spent most of his life chasing the almighty American dollar. So if we can liberate people that do this kind of work to do it more often by providing the money somehow, because there's plenty of money out there, but somehow it doesn't follow the people that want to change the world. It follows the people that want to keep everything the same. And we've talked about that this whole weekend, and it's the reason why everybody in this room's pissed off about it already. So if you want to help, here's the best thing I can suggest is find bright people, find a way to point the money toward them, and then demand some accountability. Because every inventor is going to tell you, oh, it's like the hot fusion thing. Oh, we're almost to the end of it for the last 75 years. Don't believe that crap. Track the progress and fund the people who make the progress. Get that money to flow, because otherwise we're all just, you know, delivering stuff on trucks all day and dreaming about what we could do and what we could be.
Well, back to the subject of oil. When I was in college, after I got out of the Navy in the 70s, we were told that there was going to be a global ice age. And of course, it was our fault. So what happened was there was a drastic effort to reduce the consumption of oil. And this is when my 1980 Toyota Corolla was invented that I still have. And it has a little mark on the speedometer that says 50. Am I competing with somebody talking? I think they exist in their own universe, so I'll just get louder. So at any rate, things changed. Now all of a sudden, oh, the world's getting warmer. Gee, how'd that come about? First it was getting colder, and now it's getting warmer. And I have this complication that I have to have these antennas on my car 11 feet high so that I can find it in the parking lot amongst all the six-wheel pickup trucks that are as empty as the heads of their owners. Why is it that every one of you is driving around in a 10-kiloton KUV? Can you tell me that? And I have to listen to the goddamn noise of this stuff bellowing like steers and animals? Huh? And now we need free energy so that we can have an 8-wheel pickup truck.
We can do 2 more questions.
Okay. Jim, your comment on inspiration, I think, really hit the nail on the head. Because, and Al, the comment that you made that God is in the business of, is in the creation business, and he needs other co-creators. So tapping into that thread makes all kinds of sense to me in my world as an artist, and connecting with that inspiration on a daily level, I think is the first job of my day. That's the first thing I need to do to connect and do something, because it's got to start within here, and without that inspiration. Without the inspiration, I can't take the time. I'm not inspired to be quiet enough to get the download, because there's nothing new under the sun. But the mind has been so programmed in worrying about paying the rent and spending all our subjective dialogue in the past and projecting it into the future, nothing new happens unless there's some quiet time. And that's how I sustain that level of inspiration to come up with something new, to feel the love to create. And without that, it's a mental thing, and nothing new changes. So that to me is really a powerful way to move forward in this movement. And my question is, has anybody worked with rodent coils that are shaped using that unified field shape? Has anybody been using in the electromagnetic geometry, rodent coil geometries that are shaped like the unified energy field. All the electromagnetic coils that I have seen so far are in a cylindrical shape, and in my world, geometry is the number one thing that accesses the energy from the field. So, where is that?
There's actually been some work done on the unusual properties of windings that were made in the fashion of a Morbius loop. I never really got into it too deeply, but a Morbius loop is very unusual in the fact that it only has one surface, at least from the topological point of view. And so if you could effectively produce a winding that had only one surface, it might have very unusual inductive properties. But that's just my supposition. I've never really gone there, but that might be something worth trying if you're interested.
I haven't met these people yet, but they have a lab in Florida, and we have a mutual friend, and I've been invited to go to Florida to see what has been described to me as some very incredible progress with rodent coils, and that's on my list of things to do. It's not at the top of the list. I'd like it to be, but you know how it is. So sometime in the next, maybe by next energy conference, I'll have something to actually answer that question, or maybe they'll be here speaking at the conference. So things to come in the future about that kind of stuff, but there's some great work being done in that area.
No, Jeff, go ahead. If you can make it brief, and then we'll just wrap it up.
This is an Al-Eric question based on Bill's work. If you make a water capacitor that exchanges that exchanges the has the dielectric constant self-healing for arcing inside in a glass container with the Tesla pigtail spirals that are in the Pentagon Aliens thing is the electrode, with what Eric was talking about for the top shape. With the 93 volts of electrostatic field that we always get, this is a personal energy supply as opposed to building batteries at home. So everyone's generator could use this as a storage mechanism. Do you have any comments about that?
Yeah, there's been a lot of work going on that doesn't really seem to be, at least I'm not getting finding a lot of readily available information on it, but doing the hydrogen-oxygen separation dielectrically instead of by electrolysis, as far as I'm concerned, from what I've seen, definitely works. So the situation is to work with the appropriate harmonic waveform. The harmonic waveform is a critical part. And act upon water as a dielectric to separate them by neutralizing the intermolecular binding forces. So this is a situation that's of interest for people that are trying to get the gold out of the tailings of the mines. That's in such a fine and contracted state within the matter that there's no filtration process or anything that separates it, but this is the mode they're going. So now it takes no energy to break the intermolecular binding forces by that mean. Electrolysis is a force situation. This isn't a force situation, it's kind of an unlocking situation. Now, the result of that is you have hydrogen and oxygen separated, which desire to engage thermodynamically. Now, when you go through that thermodynamic conversion, that will give rise to energy. So you have a situation with potential situation. I can't speak with absolute authority on the matter because I haven't done it personally, but it makes sense with my understanding of electricity. No energy required to break the water apart, energy derived from separating the water, and at the same time, it provides a desalination plant. I think right now that's probably the most important aspect for scientists and engineers to study, is to figure out a way to tap that phenomena and create pure water and a thermodynamic output without a thermodynamic input and no pollution.
The one caveat I had is the atomic density that you were talking about earlier, getting the dielectric density down in that sort of cell, that's the last part of that equation.
The unit I have over there providing the gas for the pump is not an electrolysis unit. You see? And we suppress the electrolysis. And as you were saying, we use the water as a dielectric, and we're separating the water not by electrolysis. It's operating as a dielectric. It's actually a big water capacitor. You see? And it's exactly what you were saying in the question. That unit is not an electrolysis unit. We suppress the electrolysis on the electrodes. And the dissociation occurs between the electrodes because we prevent the electrolysis. That's why we're able to get a couple liters a minute for 50 watts. We're not doing electrolysis. It's exactly as you stated, and that's my experience, and that's what the unit does. And if I had a chart, I could show you how the electrodes are connected to prevent electrolysis. And between them, the water dissociates. And there are some other techniques. Water, in terms of the Rodin coil, we had a question before. If the bottom of that thing I put a Rodin coil, okay, and I tune it, it's very dangerous. All of a sudden I have a lot of gas, and you'll see an electrostatic. We've had electrostatic spark. We were working in 5-gallon buckets. You got it. The dielectric breakdown. And the guys that I was working with were building them to provide gas for diesel trucks. They were in the diesel truck business. And we blew the garage down, blew the door off of the garage, knocked down a big tree. Oh man, be very careful when you put a Rodin coil. You will suddenly disassociate lots of water, but that's not the problem. We want the gas, but the problem is we couldn't suppress the electrostatic stuff that was happening, and when the dielectric broke down, and we blew that 5-gallon bucket up, and it knocked down a big tree, blew in the side of their building, and guess what? We put it aside.
Jeff, there is one patent you might want to look at by somebody named Taeheehan. I believe he's Korean, Tayheehan. I believe it's a U.S. patent. I built it. It didn't work as claimed. It was kind of a crude setup, but the concept was 2 plates coated with, the way I did it was two plates with about a 1 millimeter gap, coated it with super corona dope, which has about 4,000 volts per mil that it'll hold back. Okay, well, super corona dope is easy to just paint on 4,000 volts, or maybe about 5,000 if you bake it. So I did about almost a millimeter coating, so that held back about 40,000 volts on each plate, had the water between it. Did this at Peter's shop a long time ago. I didn't get the results because my power supply was really crude, but the idea is build up that electrostatic force there without having it jump across, and that field will, that potential there can just rip, electrostatically tug of war, rip the water molecule apart, but you don't have current moving through it. And so just exactly like what they're saying. But in that patent, he used barium titanate plates, which I don't know a whole lot about materials, but they're supposed to be. Okay, so, and Eric had a quick comment to wrap it up for you.
Yeah, one of my co-Bell telephone radicals, who unfortunately is dead now, but we discussed this a long, long time ago through the use of harmonics and doing it dielectrically. He managed to actually turn this from a scientific concept into an engineering reality. Two of the important things is to not let the gas accumulate, but to get it all out of there and don't try to store it. And then he, because of his security clearances and accesses and whatever, used the most advanced nanotechnology available to create what are called molecular sieves. Now, what the molecular sieve does is it separates the hydrogen and oxygen so they can be stored independently and they're safe. And it also eliminates the complication that when hydrogen and oxygen, as derived in the balance that exists in water, reunites, it is not an expansive process. And ultimately, it makes it worthless in an internal combustion engine other than an additive. So he had designed a system where the hydroxyl gas was created on demand. It was separated by the molecular sieves, and then it was applied, the hydrogen and oxygen were supplied to the engine in the appropriate proportions to produce the right pressure-orientated combustion process to run his Volkswagen engine. And his claim was, that I was never able to verify, but he claims that he had built a Volkswagen which basically ran on distilled water. And if there was anybody on earth that could do this, it would be this guy.
Okay. I thank everybody on the panel and everybody who stayed. Oh, okay. Just want to really appreciate all of you who stayed too. And so, Aaron, you have any announcements?
Not really any announcements. I just want to mention real quick that I have kind of created a job for myself, which I feel like one of the luckiest people in the world to be able to work with all these people that have been generous enough to share their experience and their time and be with all of us at the conference here. There is a website, emediapress.com, and that documents much of their work, and all the presentations at the other conferences are available there. And as far as this creative process, I just want to mention real quick, I don't know who would believe it, but these conferences were conceived and a lot of what's going on in my mind over 20 years ago. And so none of it is really a surprise to me. And one of the common threads that I just wanted to mention, and you know, it might almost be woo-woo talk, would be that most of the people that, well, just about everybody that I know who has the results, a lot of the results that you see at this conference today, everybody is real psychically in tune with the collective. You know, literally using those faculties of their mind and their consciousness. And when I started A&P Electronic Media with Peter, the first book we published was actually Lessons in Advanced Perception. Didn't have anything to do with energy technologies. And I added a book, you know, I'm not the greatest writer, I just kind of write how I speak and from my experiences, but Lessons in Advanced Perception and A Course in Mind Power is what I put into the catalog, which catalogs a lot of my own processes and stuff to kind of enhance that creative ability and open up different faculties in the mind that, you know, are not really supposed to be possible. But I would encourage everybody not to try to plug a book or anything like that, but just read the website, lessonsinadvancedperception.com, see what that's about, read the website, acourseinmindpower.com, and just see what it's about, because that's, to us, is actually more important than a lot of this energy stuff. So, and that's all I really want to say, and I want to thank Jeane for helping out with this, and we'll see you tomorrow. Have a good night and enjoy your dinner.
People and to be around such revolutionaries and pioneers of the free energy movement, and I'm just so grateful that I'm here and that I was able to be picked for this. I'm so grateful, and thank you so much from the anonymous donor. And yeah, I recently got accepted into SATE for electrical engineering technologist, and I'm hoping to bring this knowledge and be a pioneer myself in the future and help bring this movement even forward. So thank you.
Hi, my name is Josh Vetter. I'm from Bismarck, North Dakota, and I am an electrical engineering student at North Dakota State University, and I have one more semester left. I want to thank the anonymous donor for bringing me here. This is a great honor, especially meeting all you guys. For the last couple of years, I've been doing a lot of just private research in electric motors and batteries. I built a lot of small electric vehicles that I like to test out different arrangements and different fundamentals with the motors and driving the motors and stuff like that. So I've been working a lot with Bedini's battery charging and looking at some of Jim Moray and Paul Babcock's work. So it's very awesome. So just wanted to thank you all again for having me here. It's an honor.
My name is Ross Barable. I'm from southern Colorado, a little town called Pagosa Springs, and thank you very much to the Eric Dollard Fan Club for the scholarship to come and attend this event. This is my first year. I've been following this movement for about 4 years, and
so we have Jason and Ross were selected as the ones that he would cover the conference and lodging for these guys. And what I want to do is just have each one take just 1 minute, give me your name, where you're from, a little bit about your background, why you're here, who you're here to see, and give an opportunity to give thanks to the anonymous donor who helped make it possible for you guys.
So my name is Jason Poteet. I'm from Central California area around Sacramento. And I would like to thank the Eric Dollard Fan Club for bringing me here, because I was, especially because as I entered the contest, I'd been unemployed for 9 months. Thankfully, I have a job now, but I didn't think I'd make it back. This is my second year. So I'm here to hear everybody. But my background is, I have studied music, studied organ. I have a small pipe organ in my dining room, not the best acoustical space for it, but that came from the university I attended. So I disassembled, reassembled it, and I tuned it. Thanks to Eric, I started getting into a little bit of studying historical tunings recently, and it really got me interested in playing again a lot more. I've been a church musician as well too, but I tuned one rank of the organ to some Baroque tuning, and playing with that. I love all things that resonate, electrical and musical too, in the physical world. So look forward to talking to anybody that is interested in those things. I'm looking forward to the talk tomorrow too.
Hi, my name is Robert Davis. I'm from Canada, recently from Alberta. Really, it's just an honor just to meet all of you.
I've done looked into the things like hot fusion, plasma gasification, and other plasma diagnostics. I first got into the alternate energy field when I watched Professor Eric's lecture of anti-relativity. I kind of felt like I was wearing an uninsulated lightning rod cap on the tip of a mountain. Glad I got him laughing. But yeah, it was a great experience. Watching the lecture is quite inspiring, and I really am. I'm shaking right now because it's nerve-wracking again. But yeah, it's a great experience, and I'm quite honored to meet so many like-minded people. And definitely, I really do appreciate the opportunity that the donors given us. I've got the opportunity to meet all these great winners that I have the honor of sharing the prize with. And yeah, I'm looking forward to everyone to the final series of lectures. And yeah, that's it about me.
My name is Dejan Stojanovic. I'm coming from Ontario, Canada. I did my undergrad in mathematical physics, and right now I'm doing my master's in high-frequency electromagnetics. About 2 years ago, I stumbled across Eric Dollard's work. I don't even know how. But I've been hooked ever since, and recently I've done some minor research in Tesla coils and their applications to communications. And I just want to thank everyone for being here. It's kind of surreal meeting these people that I just see on YouTube videos, but and I just want to thank everyone for making this possible.
Okay, now before we get started, I just have one thing I wanted to mention here. If you've seen this little device with the LEDs on here, Michael Snyder of Revolution Labs was kind enough to just send me one to kind of demo and for people to play with. This will be in the back of the room. This glass disc in the middle is filled with like a ferrofluid, so he calls it a ferrofluid cell. I think he makes it on a 3D print. Before we get started with the panel discussion, one thing I want to do really quick, I did mention the 4 electrical engineering students, Dejan, Anis, Josh, and Richard, and at that time the musicians, Ross and Jason, were not here yet, but there is an anonymous donor who has been quietly behind the scenes funding a lot of Eric Dollard's work. And that's about all we can say about it. And when he knew this conference was going on, he donated some money to cover conference costs, lodging, some food, different things like that for electrical engineering students to encourage some of the younger generation to kind of get involved with this. And then when he found out more about what Eric's presentation was going to be about, the power of ether as related to music and electricity, then he opened it up for a couple people who were involved with music, which he was originally hoping to offer it up to some musical students. And surprisingly, when we ran that contest, we didn't really hear from musical students. We heard from a lot of talented people. But eventually, when everything was said and done, I passed it by Charles Berry, who is helping Eric out. He's a classical musical composer from Seattle, to have it run by him, and I sent it back to the anonymous donor to have him kind of look over it.
What I do is I've had a love affair with a folk harp for about 30 years, and I build the harp and I play the harp, and that transformed itself into designing and building outdoor acoustic sculptures in the form of wind harps. And the principle that I found a resonance with in building these instruments and listening to the speakers in this conference so far is energy resonance. And that seems to me to be the common thread that all of these electrical generating units have that allows them to really create a lot of power efficiently. In reflection on building wind harps, the first wind harps that I built usually had 48 strings, and now they have 18 strings, and that harvesting of that energy is all about resonance and finding the right geometry that resonates with the resonance of the frequencies that we're harvesting from the wind. So it's wonderful to be part of this and see the collaboration that's going on, and I am so grateful to be here. Thank you very much. Your website. My website that shows these different sonic geometries that I build is soundscapesinternational.com. So you'll have fun looking at these different harps, and they're all built out of titanium. So that's why I was interested in working with Brown's gas and changing the molecular configuration of those metals.
So hello everyone, my name is Anas Abdul-Rahim. I feel extremely out of place introducing myself in the midst of all these pioneers. I'm just a humble student. I study nuclear engineering. I'm from Toronto, Canada. I'm currently in my 4th year. I got interested in plasma, and it's quite interesting for a scatterbrain since it is quite dynamic. And I've been doing research with my professor. I'm a research assistant